Hi, Nines. Today we're looking at index law 1 and 2. So we've built upon chapter 6a. We're looking at indices. What are they? How do we convert between expanded form and index form? Today we're looking at index laws. And we're going to be able to use the first two laws of indices to simplify expressions. Just a reminder, when looking at algebra, we're going to be talking about one of two things. It's either an equation or an expression. So an equation could be something like 3x equals 9. I have something on the left-hand side, something on the right-hand side, and I can manipulate this equation to solve for x. So if I were to do x is equal to 9 divided by 3, which is 3. Whereas an expression could be something like 4 times x times y. We don't know what x is, we don't know what y is, and we don't know what 4 times x times y equals. So today we're going to be looking at these types of algebra, your expressions, rather than our equations. Once again, no retrieval quiz for today. So here are our key ideas, just 2 dot points. These are our two index laws. So index law 1 is looking at the multiplication of indices. So if we have two numbers with the same base, so it's very important, something like 2 squared times 3 squared, we can't do anything about. But if it's 2 squared times 2 squared, those have the same base. So this is what we're looking at, not this. So when multiplying terms with the same base, you just add the powers. If we were to look at this 2 squared times 2 squared example I've drawn, if we were to convert that to expanded form, that's going to be 2 times 2, also multiplied by 2 times 2. Well, if we count how many we've got in the end, that is going to be 2 to the power of 4, which is 2 to the 2 plus 2. So if we're multiplying terms with the same base, we add the powers. Index law 2 is looking at division. So when dividing terms with the same base, we subtract the powers. So if I've got a to the power of m divided by a to the power of n, that's going to be a to the power of m minus n. An example of this would be 3 to the power of 5 divided by 3 to the power of 2. Well, if we expand this out, it's going to be 3 times itself 5 times over 3 times 3. As you'd know, we have common factors in our numerator and our denominator. So this and this are both equal to 9. So if we're multiplying by 9 and then dividing by 9, we can cancel those two brackets out. What we're left with is 3 to the power of 3. Well, if we instead apply our index law, that would have been 3 to the power of 5 minus 2, which also gets us 3 to the power of 3. Let's see how this goes into practice. So if we have 3 to the power of 6 times 3 to the power of 4, that is going to be 3 to the power of 6 plus 4, which is 3 to the power of 10. You can imagine that if we expanded that into 6 threes, that goes on, and 4 threes, I can actually write this one out, we'll have 6 over here, 6 over here and 4 over here. When we add those up, we're going to have 10 threes overall. So our answer is 3 to the power of 10. Well, what about division? Well, for part B, we're going to have 7 to the power of 9, subtract 5, which is 7 to the power of 4. And again, if we look at this in expanded form, we'd have 7 nines on our numerator, 9 sevens on our numerator, and 5 sevens on our denominator. And then when we cancel out those 5 sevens with 5 sevens up the top, we'll be left with 4 sevens. So we've got 7 to the power of 4. Example 6. Well, what if we're now looking at pronumerals? They're not numbers anymore, they're x's, y's, m's, whatever number we choose. Well, for part A, it's the same process. X to the power of 4 plus 5, well, that's just x to the power of 9. Part B, we've got x cubed, y to the 4. We're going to be adding 1 to our power of 4, and we're going to be adding 2 to our power of 3, which gets us x to the 5, y to the 5. And then for part C, we've got 3m to the 4 plus 5, but we can't forget that 2 that we've got there. So what are we going to do with that 2? Well, 2 times 3, we know that's 6. So we can rewrite this as 6 times m to the power of 9. Example 7. What if we're dividing pronumerals? Well, same process, x to the power of 10, we subtract 2 from that, and then we get x to the power of 8. Part B, this looks a little bit more complicated. Let's first look at the a's. So if I've got a in my numerator, a to the power of 6, and I've got a to the power of 2 in my denominator, well, I'm going to subtract 2 from that 6 that is in my numerator. Similarly, for b, we've got b cubed. We're going to be subtracting 2 for that b squared in our denominator. But then we can't forget our 8 over 12, so we can turn that into a fraction that's being multiplied across both of these terms. So let's make this a little bit simpler. We've got a to the 4, b to the 1. Now, this is probably a good point to talk about the fact that if we have b to the power of 1, we will omit the index. We won't write it. So anything to the power of 1, as we talked about in the last video, is just itself. So we're just going to write b instead of b to the power of 1. And then with this fraction, we can simplify it by taking out a factor of 4, and that is going to give us 2/3 times a to the power of 4 times b. So a lot of simplification that we can do there. Example 8. Now we're involving multiplication and division into a single expression. So rather than multiplying or just dividing, we're now doing both. So I'm going to take this by doing multiplication first. We've got x to the power of 2 plus 3 over x to the 4. I've just changed that division symbol to be a fraction, but it's still the same idea there. So we get x to the 5 over x to the 4, which is just x, because we've got 5 and we subtract 4 from it. Part B, similar process. I'm going to do the multiplication first and then do my division. So 2 times 8 is going to be out the front. Then we also have a to the power of 3 plus 2. So there's our 3 and our 2. And then we're going to have b to the power of 1 plus 3. So our 1 is invisible there and our 3 is over there. That is still all over 4 a to the 4 b squared. And so let's do some simplification. We get 16 a to the 5 b to the 4 over 4 a to the 4 b to the 2, or b squared. We can do some more simplification here. So 16 quarters is just the same as 4. A to the power of 5 minus 4 is a to the power of 1. And b to the power of 4 minus 2 is b squared. So our final answer there is 4ab squared. And that is all for this video. Thank you for watching.